This is TWIS. This Week in Science, episode number 886, recorded on Wednesday, August 3rd, 2022. None of this is right. Science! Hey everyone, I'm Dr. Kiki, and tonight we will fill your heads with dead pigs, old people, and shrimp bricks. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. The following program is meant for therapeutic purposes only. Any knowledge or entertainment found in the minds of the audience is purely coincidental. While the subjects of the conversations are sourced from the current cutting edge of published scientific studies, selected only from the finest well-established scientific publications submitted for scientific publication by researchers and institutions that are credentialed experts in their fields, the real purpose of the show is subliminal relaxation therapy. As you listen, a series of tones will play imperceptibly just beyond the range of human hearing at frequencies designed to alleviate stress, create focus, and unlock creative potential. Occasionally there will be an advertisement. That might have been one right there. But don't worry, it won't be annoying. Why, you won't even know that you are hearing it, though you may find yourself uncontrollably donating to the occasional worthy cause. So sit back, relax, and get ready for another episode of This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin and Blair and everyone out there. Welcome to another episode of This Week in Science. We are back again to talk about all the science that has happened in the last week. Well, all the science that we want to talk about, because there's always so much.
There's so much.
All the science we have time to talk about. We only have a tight 90 minutes to tell you these stories. Otherwise, we'd keep talking.
Just a tight 90 of an amuse-bouche of science.
Boosh. It's a moose-boosh.
It's like appetizing.
Learning
it just
already.
Gets you excited. It's just all the
An exciting bite.
Zhuzh you up.
You
A
know.
little exciting bite. Okay, I'm going to talk about dead pigs. I've got also some embryos and electricity in biology, and then some brain stuff because I love the brain stuff. Justin, what do you have?
Oh, I've got a story I'm excited about. I got the oldest evidence of humans in North America ever found yet. CBD, anxiety in teens, and a long global warming thing at the end, which somebody's gonna have to come in behind me on that one with a really upbeat story.
Yeah. Okay. Yeah. We've been beating this drum for a long time, so let's just
Yeah,
pound
but
it a
this
little
one,
bit
this
more.
is
Okay.
yeah. It was still we're gonna need a little bit of a pick me up. This conversation.
All right, Blair, what is in the animal corner?
Yes.
Yeah.
I have the previously mentioned shrimp bricks. I also have spider tricorders, I'll just call them. And then I also have a story about, what did I forgot already. Oh, whale eyes and bee pain. So there you go.
Whale eyes, bee pain. You didn't know this was a science show, did you? Everyone,
I trust.
yeah, I know, right? We're going to jump right into the show here. But before we do, I just want you to know that you can subscribe to us on your favorite podcast platform if you haven't done so already. We're also on YouTube, Facebook, and Twitch. On Twitch, we are TWIS Science. We're also TWIS Science on Twitter and Instagram. And if all of this is just too much, go to our website, twis.org. And additionally, we broadcast live each Wednesday evening at 8 p.m. Pacific time. at YouTube, Facebook, and Twitch. So make sure you get those notifications on so you know when we are live, because we're live right now. Woo! Okay, let's talk about the science. Dead pigs, you ready?
Yeah, bring
Dead
it.
pigs.
Okay, a couple of years ago, I talked about technology called BrainX, in which Yale researchers had developed a system in which to keep the pig brain after death less dead. And it was a technology that enabled, it's like a synthetic blood and a synthetic system that perfuses, or did in the past perfuse, the brain, allowed that brain system to live a little bit longer after death, even though they weren't going for that brainy electrochemical activity that normally is consciousness.
Wasn't Blair's head in a jar
Right.
that they were shooting for?
Right.
But this was
not Blair's
early
head in a jar.
experimentation level.
This is early experimentation, but it's, it's coming from Yale. This is also very fringe kind of stuff, but not this, near death kind of stuff, right? We're taking pig heads.
Which would you expect that were coming out of Yale?
They had amazing results. They were able to restore cellular functions, able to get a lot of the neurons back online. And because of what they were doing with BrainX, they were like, dude, why don't we do this with the rest of the body? And so they created a system called OrganX. And with OrganX, they have also been able to restore cellular function to the point of metabolism after death. Wow. So they subjected pigs to death, which is stopping respiration, stopping heart action, stopping brain activity, and then allowed this perfusion of their blood replacement, this analog of blood that they've perfused through the system. And not just, it wasn't just like it's okay, some stuff kind of kept going. Metabolism started again. Cells started working again. And so this isn't necessarily like, we're going to bring dead people back to life. But what this could potentially do is allow for the extension of organs that could be used for transplantation.
That's exactly what I was thinking. Okay, cool.
That's not what I was thinking. This is probably in the lab of Dr. Frankenstein.
Frankenstein, please.
Frankenstein.
Yes.
Right there.
Yes.
Yeah, because this is, of course, we have the ability. We've had the ability. This is like old human technology, medical technology, being able to swap out an organ, because we're a collection of spare parts at some point.
Right, but there's the extreme rush that we just talked about even last week.
Yeah,
with a story about trying to get organs to people in time, and if the organ is coming from someone who's been dead a while, or if the organ has to travel a vast distance, if this can like reinvigorate it, that would definitely change the game.
It would totally change the game. Mm-hmm. There is the possibility also of this being used to keep the very rich alive longer, or how else could it be used to extend the lives of individuals whose organs are failing? It's a very interesting technology whose, I think the big application is organ transplantation, keeping organs alive longer, keeping people who have recently deceased, at least in a metabolic state, longer, so that their organs can be harvested and used for other people in a better manner, so that we don't lose as much. But this is
it seems like it seems like a much more applicable experiment and study and method, because the brain, even if you preserve the brain and kept it alive in a jar for a week, a month, or even a year, you're not putting it anywhere. It's not going back. That's one thing we haven't been able to swap out yet is a brain. There's a little bit too much connectivity involved and compared to any of the other organs. So
yeah, they started with the brain with Brain X, and that was like this interesting, complicated thing. And then now they're doing the organ stuff, and the organ stuff actually is working, of course, better than just the brain stuff. They were able to restore circulation throughout the body. They were able to keep a lot of the deterioration that starts occurring after death from occurring because the body the cells kept metabolizing. The nutrients that they needed were there. A lot of the genes. So if you start going at the gene level of like, okay, what are the cells actually doing? Are they dying? Are they gasping for air? What's happening? A lot of the gene activity suggested that they were really metabolizing and that the cells were doing what they're supposed to do at the cell tissue level.
They have what they need. They're going to keep going to work.
Yeah.
Fada in the chat room. They're messing with forces of nature they do not fully understand. Yeah, that's what science does, pretty much.
That's what science says. But I think this is outside of the brain. This is fascinating because, like we said, it could really change the way that, the way that transplants happen, the way that organ transfer happens, the way that so much happens. If we can get this part of, can we make bodies live longer?
Which is also why I'm always hesitant to make fun of a study that seems like absolutely ridiculous. Like last week's spider robot story. It's going to be a while before that has an application, I'm sure. But they have this thing that seems like this preposterous thing to even be opening as a line of inquiry, and then here we go. A year later or whatever since the last time we talked about this, and here is an application that could be revolutionary.
Yeah.
So don't judge. Don't judge the fringy science experiments.
Don't judge.
It's
they
never the
great
end
places.
result in the first experiment.
All right. Speaking of fringy science, let's talk about old people. How old are the oldest people in North America, Justin?
I don't know if this is the least bit fringy. This is the Hartley Mammoth locality, which is a site in New Mexico studied by scientists with the University of Texas at Austin. And the site has a bunch of smashed up mammoth fossils, which by itself would be awesome. Finding a site with a whole bunch of mammoth fossils. Very cool. But these mammoth fossils are especially interesting because they have blunt force fractures and are found amongst bone flake knives that have worn edges. The site has archaeological signs, chemical signs of controlled fire, revealing the scene of an ancient hunt, perhaps, and butchering site.
Whoa.
Yeah, so they got the bone blades to break up mammoth meat into manageable pieces, fire that's maybe rendering the fat. Thanks to carbon dating analysis on collagen extracted from the mammoth bones, the site also comes with an age. About 37,000 years old. So, this is New Mexico, where we have the site of the 20-ish thousand-year-old white sands footprints that were discovered. But this is considerably older than any other North American site, except for perhaps there is the cave where they have found signs of human activity in Mexico. They dated to around 30,000 years. But for North America, 37,000 year old human activity is now the oldest. Lead author of the paper, published in Frontiers in Ecology and Evolution, is a University of Texas Austin paleontologist, Timothy Rowe, who usually doesn't study mammoths or ancient humans, but when a tusk of a mammoth was found sticking out of a hillside on his land, he thought, maybe I'll make this a thing I study for a while.
As a treat, for a hobby.
As a treat.
Yeah.
That's right.
Like, what a lovely thing to find. Among other finds, CT scans taken by the University of Texas high-resolution X-ray computed tomography facility revealed revealed bone flakes with microscopic fracture networks akin to those freshly knapped cow bones and well-placed puncture wounds that would have helped in draining grease from ribs and vertebral bones. So while there may be more than one way to skin a mammoth, there are only a few ways to do so efficiently. According to Rowe, the butchering patterns are quite characteristic. So also no evidence of animal tooth marks on any of the bones. So these weren't
That's
at
important.
any time scavenged.
Mhm.
Which is also important because it also likely means that the flesh was rendered without being exposed to scavenging rodents even. Chemical analysis surrounding the bones showed that fire particles came from a sustained and controlled burn, not a lightning strike, not a wildfire. Materials also contained pulverized bone and burned remains of small animals, mostly fish, which can tell a tale of its own because this is at a pretty high altitude, 200 feet of altitude, higher than any other river or ways away from existing waters. So could be a completely different environmental landscape at the time, which actually we know it was. But also it might mean that people were traveling with the fish. They also found birds, rodents, and lizards. So it's also, the site is being used beyond, they've got this mammoth kill, which you would think, that's it, we're just going to live off of mammoth. But there's a diversity of game that's also being cooked at this site,
Right.
which indicates maybe a knowledge that you kind of need that more diverse diet for health reasons, not just availability. So tools, butchering, fire, diverse caught meals, and 37,000 years ago in New Mexico. These are also important. They found what they're describing as these bone tools that could have been used to render. The Clovis site, which at one point people were saying was, this is the oldest evidence of Native Americans in North America, is stone tools. There was no evidence of stone tools at the site.
Huh.
So this shows either that there's a pre-Clovis culture that was different, or it shows an evolution of technology. We don't know because we don't have human remains involved in any of this, which is very frustrating. But hey, I've been saying it for a while. We're going to continue to find older and older North America, and it keeps getting older than the things that they tried to pin in Northeast Asia as the ancestor culture that came to North America. It's tough when the North American culture is there for tens of thousands of years already. So
Yeah.
much more in these stories to be coming in the future, I am sure.
That's just amazing. I mean, it was last year that you reported the footprints that took us back 24,000 years, and now suddenly it's beyond that, 37,000 years. Like, this is a leap from those footprints. This is something totally different, and it's I'm surprised there aren't any tools, but it's interesting.
Well, there
at the
are
same
tools.
time.
There are tools that are bone,
right?
but nothing stone. Nothing stone. Which is which is interesting.
It's interesting
because stone tools are much older than that. Much older.
Much older.
But although, and that's the other kind of weird thing, stone tools also seem to originate in non-modern humans and stay with them, whereas humans kind of get a little bit. We moved around in our technology quite a bit. As well.
Maybe the bone tools were better.
Yeah, well, maybe they put down the stone tools and we're like, the bone tools, I like them.
And it could be that the bone tools were also for rendering, and the stone tools weren't being used for that. You know, they might have found that they're bone cutters, or they might have been precious enough to hang on to and not leave anything at the site, because again, there's no real signs of extended habitation. The picture, at least, that it painted thus far is one of, looks like you take down the mammoth and you don't carry it with you back to you got to cut it up apart on site. Even a much smaller game you would want to render on site and take the pieces away. But the site was also discovered in 2013. But it took, a long time to get around to realizing it was a really valuable thing to study because the bones are smashed up. They're broken up into pieces, so it's not like, oh, we have this great fossil we can send to a museum, and the paleontologist is like, yeah, it's not old enough, it's not interesting, it's not even 1,000,000 years old. Why would I even bother looking at that at first?
It's not even 1,000,000. Why would I look at that? Oh my goodness.
That's no dinosaur.
Yes, no. Yeah. Okay, Blair, tell us about some spider silk.
Oh, yes. I have a couple really cool stories about technological advances based on inspiration from the animal kingdom. So this first one is about spider silk as optical fiber for medical analysis. Researchers have harnessed the light guiding properties of spider silk to develop a sensor that can detect and measure small changes in refractive index of a biological solution. So they think that this could one day be useful for measuring blood sugar and other biochemical analysis. Glucose sensors are used by people with diabetes currently, but these devices are invasive, uncomfortable, and not cost efficient. They rack up. With spider silk, they think that they could use a material including spider silk to optically detect various sugar concentrations in real time. In fact, they're currently developing an app so that you could you could do it on your phone. So they found that these optical fibers could determine concentrations of fructose, sucrose, glucose, and that it was all based on the solution's refractive index. Spider silk was ideal because it can transmit light like an optical fiber, but as we know, it is also very strong and elastic. So they had spider silk from giant wood spiders, Nephila pilipes, which is native to Taiwan. They enveloped the silk, which is 10 microns in diameter, with a biocompatible photocurable resin and cured it to form a smooth protective surface. And the spider silk was at the core, resin outside, and they had a biocompatible nano layer of gold to enhance the fiber's sensing abilities. Now, is it just me, or does this sound like the coolest wizard wand you've ever heard?
Right?
And I was immediately very upset that in like Harry Potter lore, spider silk is not a core that you can have in your wands. I think that needs to be fixed. But anyway, back on this.
Fair enough. I got it.
Especially with like gold on the outside. Come on. Anyway. Yeah. So they tested it by immersing one end in a liquid sample, connect the other end to a light source and a spectrometer, and they were able to determine all these different things. It is reusable, it's cost effective, it's easy to use, offers real-time detection, and because it's compact, it could actually allow access to hard to reach areas like the brain or the heart. So beyond diabetes, this could do all sorts of other things. So it could be implantable in medical devices. There could be all sorts of things that this could be used for. And as I said, they're working on an app so that they could implant it in a medical device and then have it just sync to your phone, basically. And it could be giving you real-time data on any sort of, all numbers of things, anything that's something that's in solution. So in blood, you could track your lactose or your fat amounts. You could do all sorts of things with this. So once again, spider silk has a really cool potential application.
Yeah.
I don't want spiders in my blood, but the silk
Just
might
their
be okay.
silk, you know.
Might be all right.
Yeah. Do you want to hear my other story about Okay, great.
Go for it.
This is about animals contributing to technology, and this is about the shrimp bricks that were teased earlier. And you guessed it, yes, shrimp shells in cement makes them stronger, and it makes them take less or more time to harden, which is actually helpful in the cement game. So the nanoparticles from shrimp shells into cement paste had these kind of benefits. And the cool thing about the shrimp shells is that seafood waste is a big deal also. So you could actually take seafood waste, add it to cement, and you could be helping multiple problems at once. So you have the seafood waste, you have the strength of the cement, you have how long it takes to cure, which you want it to take longer so you can form it into the right shapes and you could transport it and all these other things. And also, it would lower carbon emissions, which concrete is a large contributor to carbon emissions. So there's a lot of stuff here about how they like figured out the specific amount of chitin in crab, shrimp, and lobster shells combined with the calcium carbonate made an additive to the cement that had all these. There's lots of math here, but essentially the long and short of it is that it made it stronger, made it take longer to cure. The amount of cement they had to make and their compression of it was altered such that carbon output was way lower.
Okay, that's good.
Nice.
Yeah,
That's the thing.
and where was it? 8 million pounds of seafood waste is created annually. Most of that waste is dumped directly into the ocean. So also you could just leverage that exact waste into creating these nanoparticles, inject them into cement. You have all these problems solved.
Yeah. Smart.
Yeah.
Cement is one of the biggest polluters for carbon dioxide, so that's huge.
Mm-hmm. Yep. Absolutely.
Absolutely huge. How about working on embryos and trying to figure out how they develop and keeping them alive long enough in the lab to really understand them and see how long they'll develop, and maybe at some point they'll develop into a whole fully formed human or other.
You talking about land
organism.
bags or what?
No. So I'm talking about the fact that researchers have been trying for a very long time to create a system in the laboratory that will allow us to simulate development as far along as it can possibly get before we have to turn it off and say, nope, no further. And so researchers have made artificial mouse embryos from stem cells. They haven't used any sperm or eggs, and they have this really cool bioreactor to make the creations work in the way that they do. They simulate these embryos, and then they have this Ferris wheel type contraption that they have developed through trial and error to kind of agitate these little embryos to make them actually want to turn into embryos as opposed to just dying, which happens after a few days. So what we've determined is that this agitation is very important for the actual creation of the embryos and the embryos wanting to live. Anyway, This Week in Cell researchers have reported their new development of enabling early development of embryos to at least 8 days of development, which is like a huge developmental threshold because we've never been able to get there before. We've been able to get mouse embryos outside of mother body for about 11 days, but human embryos have not lasted that long. And so this Ferris wheel of turning all the embryos and creating a nurturing situation to allow that to happen has finally allowed these researchers to get to a point where they're able to get segments that become skeletal muscles, developing brain and spinal cords, the beginning of another number of organs, and gene activity in 40,000 or more embryoid cells. Everything up to that 8-day mark is exactly where it's expected to be. No deviations. So we are extending the length of time that we can create development in a laboratory.
And potentially opening a pathway for cloning carnies.
Carnies, exactly. The Ferris wheel carnies. So the big thing now is that, like we said, with these mouse cells, no sperm or egg required, this is the next step. Can we take human adult cells. This is, using not embryonic stem cells, but adult stem cells. Can we take stem cells from adults and then create embryos where we can, with a person who has some mutation, a disease, can we study that person? Can we study the disease? Can we start looking at what's happening in the developmental stages of that disease?
Wow.
Yeah. And so it's getting to a much further along state where you've got a neural tube, you've got a beating heart, you've got the beginning of the development of a brain and a tail. It's very exciting. It's also, for people who might be worried about where this can go, it is concerning, where can we take this? Where is this all going to go? Along with like the death end of the spectrum with the pigs from earlier, because come into
it's actually right where my brain went. My brain went to a organ farm of Justin for Justin. Which
for Justin,
yes. One that matches my DNA. That I, Justin, you need a new liver, kidney, gallbladder, and maybe your right lung could use a new. And I thank goodness I've got one growing at a lab somewhere, and I can just go get it.
Justin Q's waiting right there.
Oh, but how's it? You have to go to the lab and get it done right there. No. There's this pig brain organ study that they'll send it to me via Amazon now.
We're getting there. Like it's not Amazon level easy. It's definitely not going to get there 24 hours kind of easiness. But this is it's very, in terms of the science, it's very exciting because this allows much greater detail on how we understand development to take place, and also for understanding the underpinnings of disease. When do mutations really start to affect the brain? When do they start to affect different organs? How do we know the way that they work? So we can start to figure out targets for therapeutics and like fixing that kind of stuff. But it's also, there's some philosophical issues here. Like, how long does it go? How long do we let it go?
I don't know.
It's fine so far. 8.5 days. It's 8.5 days. It's not conscious. It has a beating heart, but it's not conscious for sure.
Oh gosh. See, that's the other thing. Then what if this? Oh, we got your organ farm there, Justin, but unfortunately, it's conscious.
It's conscious. Sorry.
And technically,
say please.
Has access to your bank account. Huh? What do you mean? Well, it's you. So.
You sound kind of anxious. You want to take some CBD?
Yeah, I don't. I need the opposite of it. I need something that makes me more anxious. I have a lack of anxiety. However, for a very decent amount of the population, according to this, perhaps even a third of Australians, which this study was based in, do suffer from some form of anxiety, which is not the anxiety you feel when you are nervous or uncomfortable, but anxiety that is so bad that you cease to function as you normally would be able to. Maybe lack of sleep, maybe you put off going into work or avoid social situations, can have elevated heart rates, all sorts of things can take place with an anxiety severity. So this is an Australian pilot study that showed that CBD reduced anxiety amongst young people with hard to treat or treatment resistant anxiety. I can never say this word. I don't know why that is. Cannabidiol. Cannabidiol, which is what CBD is. Youth anxiety pilot study. It's a 12-week trial to test the feasibility, safety, tolerability, and therapeutic effects of CBD in reducing anxiety severity in these young people. There were 30 participants between the ages of 12 and 25 They had diagnosed anxiety disorder and had failed to show significant improvement in anxiety severity after 5 cognitive behavioral therapy sessions within a year of this study. Participants started on a dose of 200 milligram capsule of CBD, which was increased to 400 after 1 week, and those who did not show improvement in their anxiety systems had their doses increased up by 200 increments up to 800 milligrams per day in the study. All participants were also offered biweekly cognitive behavioral therapy on top of this. The research was conducted by Origin, a nonprofit youth mental health organization with support from the University of Sydney. I don't know if the United States even has organizations like this that are completely focused on youth mental health.
They do. They're probably just underfunded.
Yeah. Professor Paul Amminger, who is the lead study author, said the level of improvement was remarkable. Young people had fewer panic attacks, could do things that they were previously unable to do, like leave the house, go to school, participate in social situations, eat at restaurants, take public transport, or attend appointments by themselves, according to the professor. An amazing change in the group, which has had treatment-resistant, long-standing, severe to very severe anxiety. The pilot study found that CBD not only helped to reduce anxiety, but did so without all of the nasty side effects of traditional medications. This is, again,
Nice.
from the professor. We did not see side effects like suicidal thoughts, irritability, or sleep problems, which are not uncommon in people taking SSRIs.
Yep.
Yeah, your anti-anxiety medication that gives you suicidal thoughts does need to find an alternative. My goodness. Although the findings are promising, they say further research is required. Next step is to do a randomized controlled trial. Such a trial would then also be a larger group, looking for 200 to 250 young people to, according to the professor, Embryo, enable us to say with some certainty that there is or is not real treatment benefits and effects. I'm trying to make sure that they didn't get the odd hit with their small sample size or some sort of placebo effect and that sort of thing. So next step is to interrogate their initial pilot study findings with a much bigger, more rigorous version of the study.
Good. I mean, I think that's the big one is this any different from placebo? And then, it seems to have lots of good aspects to it. So let's compare it and really see how it does in a larger study.
Yeah, and it's a pretty, definitely more research needs to be done for anything to be, I don't know, for us to ever understand anything. We have to have so many looks at it. But the fact that this is not a light anxiety group. This is a therapy resistant group already that are classified as severe to very severe. This is a hard group to try it out on in the first place if you were looking for a result, which they aren't. They're looking for ways to improve mental health. They're not looking for a product to do good, bad, or indifferent. They could care less. They're not involved in manufacturing CBD. And
something that doesn't have the suicidal ideations that SSRIs are known to cause in different groups of people. That's really amazing.
And sleeplessness. Sleep is such a restorative, necessary part of human health, mental health, that if you've got anxiety and then don't sleep on top of it, the next day's anxiety, I'm sure, is much worse.
I will be very interested to see what happens with a larger study, because I feel like, especially when you're dealing with humans, of any study on humans, when you have a smaller sample size, it's really easy to accidentally get confounding variables involved, right? Like you said that all these people are resistant to, their anxiety is resistant to therapy. Are some of them still seeing a therapist, and those two things combined worked? Do some of these people have places to go home and be calm, and other people do not, and that will contribute to their anxiety? So there's all sorts of things.
Well, they did have this was combined with therapy. They had 2 weekly sessions, so it is
right, but also who has a good relationship with their therapist? and who maybe does not, right? There's all sorts
Sure.
of
So
human
many
things that are
variables. Yeah.
happening
Yeah.
that the
Yeah.
only way to overcome those weird one-off variables is to have a huge sample size.
Now, to be fair, there are larger studies that have been done on adults that have shown positive results. So this is now we're focusing it on an age group range
Yeah.
that's younger and separate with different issues. Maybe, and it's apparently, according to this study too, it's not part of their study. It's something they assert in the article here, is that it is the leading mental health reported issue amongst these teenage, this youth group, this 12 to 25 year range group. Anxiety is the highest reported mental health issue. So
These
that's
days,
also
yeah.
why it's being focused on in this way. But yeah, no, I think it's just a fascinating thing that this was a banned substance, and possibly is still in some places in the United States,
Yet.
with
Yeah.
a therapeutic ability or potential that is much better than the pharmaceutical one. Like, it's always puzzles me how these things happen.
How that
Well, and
happened?
Fada in the
Hello.
chat room brings up a really good point. He says, come on, what could possibly go wrong? I will say there are definitely drugs out there that have been approved for market with sample sizes probably this small, with way more side effects. It's out of all Fada's kind of right here. Like, if there's a potential that this could be helpful, there's a lot more help than hurt out there. And so it's an interesting point, is that, like, of all the drugs that have been approved out there, I wonder if there's an extra pressure to prove it further beyond any reasonable doubt because of the stigma, right?
Yes.
Yeah.
Well,
absolutely.
Or it's just the fact that it is now able to be studied. Because for a long time we weren't even able to study it. Now that it's available, and gosh, anecdotally, there's been a little bit of self-medication in the human population for a long time. And people
The THC is different from CBD, and this is CBD related. And so the CBD is more the hemp side of things. And so it's actually it's interesting. It's an active component, but
it's an active component. But the point of that is that if you're getting your medicine with a spoonful of sugar, you're still getting your medicine.
Your medicine.
Even if,
Very good point. For those of you who are interested in how various compounds have their effects in the body and how different metabolic actions take place, something that's very important is an enzyme. Enzymes are catalysts. They grab onto proteins and they have a magic match. And we talk about the lock and key kind of fitting that allows things to occur. And these enzymes make things speed up. They make things go faster and better and easier than they would if you just let natural dissipation take place. So enzymes are very important. What we don't understand is exactly how they work. What we've figured out is that every molecule is its own little geometric world, and the angle of different parts of the geometry of that molecule is really important for how things connect to other things. So how the positive or negative charge, how positive or how negative things are. And when this happens in terms of an enzyme, apparently how open that enzyme is very specific to the thing it wants to grab onto. It's like much more, that lock and key analogy that we have talked about is much more accurate than than we've really thought about. It's like this general analogy, but it's actually pretty accurate. And so these researchers who are at Stanford, they just published in Nature Chemistry their study into not just the charges on the enzymes, but the direction of those charges as well. So how big the charge is and where it's pointing. And they traded the hydrogen ions in a lot of molecules for deuterium, because deuterium is this radioactive molecule that we can actually monitor a little bit more easily. And so they were changing things up for deuterium, but basically it's the same as hydrogen. And so they were able to start getting a real picture of how various enzymes work. And so they were looking at alcohol dehydrogenase and some other enzymes and really starting to figure out how they work. But they're really measuring vibrational frequencies in molecules based on the wavelength of infrared light absorbed by the chemical bonds. So we're at this level of light being absorbed by chemical bonds, and that changes the vibrational frequency. It changes like what is reflected and what they're able to measure. And so the shifts in these vibrational frequencies were able to reveal information about the electrical fields that were present. And so from that, they're able to start really measuring how alcohol dehydrogenase is able to work as an enzyme to break down alcohol and all the work that it does. But they're really trying to create a probe that can be used for more enzymes and more molecules to really understand not only how do enzymes work, but how can we create enzymes? How can we make enzymes better? How can we target enzymes? How are we messing enzymes up? What are the things that we're doing that are screwing enzymes up? So they're really trying to figure out how we can work with enzymes to make our biology better.
Yeah, and anything we can do to speed that up, because of course we do. The biotechnology is larger portions of it are enzyme driven, and so one of the things that biotechnology does is they'll take an enzyme and work it into an organism and have that organism mass produce it. So if we have better ways of customizing or checking the work, you go and you engineer this enzyme that's supposed to do this function, and if you can test it, I suppose, before having to get it into bioreactors and grow it out and
Exactly.
test it on a larger scale, you get higher throughput and you get more efficient search for the next bigger, better, more efficient enzyme.
Yeah, and when we think about molecules, it's all like, oh, a molecule, but we don't really think about the fact that at the really small scale, what's happening is electric and magnetic interactions. And so what we really need to figure out is what is the electric field orientation for an active site in an enzyme, and can we make that? Can we copy it? And so this is going to help us get there. Can we build our own? Have we finished all of our little our stories for the first part of the show?
We got our first half stories in. Yeah.
Yeah, got it. Thank you, everyone, for joining us for this episode of TWIS. We are so happy that you have joined us. If you enjoy the show, please tell a friend to listen today or watch. We're on video too. Hey, so right now we're going to jump directly to this part of the show, This Week in Science, that we love so much. It's called Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have whale eyes.
You do?
No.
No.
I have a story about whale
Put
eyes.
them back.
So, whales, they're wild. They're wild because they were land mammals that went back to the ocean. They were like, no, it was better back there. So they had a whole evolutionary history where they were on land, and then they came back. So scientists have been spending a lot of time trying to figure out what aspects of being a whale happened on land, what happened when they were kind of in the middle, and what happened once they had moved permanently back to the sea. So this is a study from University of Toronto looking at early whale ancestors and specifically their eyes to try to figure out when they started going deep sea diving. So the common ancestor of living whales, according to this research, was already a deep diver. They were able to see in the blue twilight zone of the ocean, and their eyes could swiftly adjust to dim conditions as they rushed down to the deep, deep ocean to forage, and then adjust back as they moved back up towards the light. The deep sea part of whale foraging has been a question of exactly when that happened for a while, because not all whales do that. Some whales are shallow foragers. So is that something that happened later on once they were all in the ocean permanently? Or is this something that their previous ancestors that were amphibious did, the ones that went back and forth from land to ocean? So this finding to me sounds correct also just because, that's what pinnipeds do. Lots of pinnipeds are deep sea divers and they still go out onto land quite a bit. So there's a lot to eat down there. It makes sense that they would be trying to take advantage of this. The way they did this research is what's actually really interesting, though, is they were able to look at whale fossils on a molecular level, focus down on a particular protein, the rhodopsin protein, which absorbs light and sends a signal through the retina to the brain. And then they were able to use data models of the rhodopsin proteins from a variety of living whales and related mammals. And then that showed a gene sequence representing the rhodopsin in the common ancestor. And from there, they could extrapolate the kind of the family tree of what was happening with this protein. And so then what's really cool is they were able to express the gene that created rhodopsin in the lab in grown cells to resurrect the protein in purified samples. So this is a pretty novel way to try to figure out evolutionary history by growing extrapolated proteins. And so the biochemical properties of that, they're calling resurrected protein, they were able to compare it to land mammals, found that early whale rhodopsin was more sensitive to blue light that penetrates deeply to a degree that exceeded expectations of normal land mammals. So it also suggested that the retinas of the early whales could respond rapidly to changes in light levels, and therefore this early history of whales before they diverged into these different feeding strategies were deep divers. And that means that their eyes were adjusted to that, and therefore that was kind of the baseline model. And then they specialized beyond that. So pretty much as soon as they got into the ocean, they were diving deep, and potentially before that.
That's amazing.
Yeah.
So it wasn't just, because we know whales they're returned to the ocean.
Mm-hmm.
They weren't just evolving in the ocean. It was land mammals that went back.
Right.
So this is fascinating.
Yeah. Yeah. So these guys, it sounds like, you would expect like, well, I'm here. And some of them evolved to go deep. But no, they were all deep divers before. And then some of them stopped having that ability later on because they didn't need it because they were shallow animals. Yeah.
That's cool.
So this is a cool study for what we learned about whales, but also because it showed this gene extrapolation model to resurrect proteins, and that it worked, and you were able to use that in a comparative model to figure out evolutionary relationships. Very cool.
Old genes. I like it. Yeah. I know we have them too. Old genes. Let's resurrect them.
Yeah. Maybe give them a wash. Anyway, next let's move on to whether bumblebees feel pain. What do you think? What's your guess?
Yes.
No, it's a bee. Bees, there's no pain being a bee. It's too much work to be done.
Well, much like how Justin's talking, the historical expectations of bee brains was that they were regarded as simple reflex automatons. They respond to stimuli with withdrawal reflexes. So basically just like, nope, don't want to be there. I'm backing up. I'm not even thinking about it. So the way that you generally think about pain, the experience of pain is that there's a certain self-awareness of recognizing that pain is painful. Like, why do we feel pain? It is a signal from our brain to stop doing what we're doing.
Right.
So it's
Yeah.
more than just a reflex. It's a signal that, first of all, stop doing what you're doing, and second of all, more importantly, don't do that again.
Right.
So, yes.
Learn from this.
So, Kiki guessed it, this piece of research from Queen Mary University of London shows that, yes, bumblebees most likely feel pain.
Wait a sec. What's with that qualifier?
Most likely, yes.
Because we can't be in their brain. Their brain as it is a clump of neurons. It's not even really a brain. But so the study, I will explain the study method.
Mm-hmm.
It is, without being physically in a bee body, it's going to be very hard to qualify what pain feels like as a bee. Okay. But based on the scientific model that exists, it sounds like they can respond to pain. So here is the model. So they used a motivational trade-off paradigm. This is where animals have to flexibly trade off competing motivations. Bees were given the choice between an unheated, just a normal box, or a noxiously heated 55 degrees Celsius box. Obviously, you're going to stay away from that heat. But they had different sucrose concentrations inside. Some of it was better quality sugar water. They marked the quality of sugar water by colors. So this is important because first you have to teach the bee red means the good food and blue means the bad food, or whatever. I don't know what actually colors they used.
Previous studies has shown you bees can be reasonably well trained.
Mm-hmm. And so they were able to learn which color. So we'll continue with my guess of red. So we'll say that red is the good food. It's the delicious food. Then when they put, both feeders had the high quality food, and one of them was noxiously heated, the bees avoided it. They didn't want to go in there. But then when the bees saw that the better food was in the noxiously heated, the yucky box, they would go in there anyway. Now, it's important to recognize they were using their little bee ganglia, their bee brain, to go, that's where the good food is. It's going to hurt to go in there. I'm going in anyway.
Yeah.
So that is the thing. If it was totally a non-cognizant reflex, they wouldn't go in to the painful space, no matter what was waiting for them in there. But the fact that they can
take the path of least resistance.
Yes.
But prioritize the best meal. So if it,
yes.
Okay, that makes sense. I think that's what I do.
Right. And so that's the point, is that they are doing a mental trade-off. They are associating higher sugar reward with a particular color. Then they're saying, okay, it's going to hurt to go in there, but it will be worth it because it has the better sugar. I'm going in anyway.
But now you're saying hurt. Is it just sweaty? Is it just
right? Is it pain, or is it just
if you were in a room that was 55 degrees Celsius, I'm going to guess you would feel some pain.
I don't know. I grew up in the Central Valley. I feel like
So anyway, they're saying that this is consistent with other tests in other animals as a capacity to feel pain.
Yeah.
Okay.
So this is the trade-off in the central nervous system. They're making a cognizant choice. Mm-hmm. But this is where they say, because this is a subjective experience, it is not a formal proof.
Right. That's exactly it. Mm-hmm.
This shows the possibility, and I would say probability, of insect pain and or suffering. And so the problem is that in most, maybe in all countries, but in most countries, insects aren't protected.
Right.
The same way that other animals are in lab experiments and in other kind of humane treatment welfare laws. So this is one of those things where you have to recognize, if you've got neurons and you've got a nervous system and you can sense sensations as an animal, I would argue it's pretty handy to be able to feel pain.
Or at
Well,
least
yeah.
discomfort. Or at least we call it pain,
Yeah.
but we have a pain scale, right? So is it pain or is it just discomfort? And it's the trade-off between a little discomfort and a bit of reward, a lot of discomfort and a lot of reward. What is the trade-off and what is important to the animal? What is more important, right?
And I would
How
argue
much?
beyond just a trying to be humane framework, which is important if you're going to have animals in experiments or in research facilities or in livestock scenarios, as we've talked about, on the show, that insects are potentially the livestock of the future, then that is something that should be considered, of course.
Yeah.
Additionally, the thing that's important to recognize is if insects can make these preferential decisions and can feel discomfort or pain or suffering or whatever you want to call it, then their comfort should be considered in scientific models.
Right. That makes sense.
Because remember what we learned about mice, if they're too cold,
Mhm.
they mess up experiments. So if you're using insects in experiments, if that fruit fly is too hot and it won't act how you want it to act in a mating experiment, as Drosophila so often is, that could be messing with your results.
Yep. That is the key point. Very good point there. Yep. It's going to mess with the way that things work out.
Yeah.
Not whether it's a philosophical, do they feel pain or not, but more so, how is it affecting their behavior?
Yeah.
How is it impacting them?
Right.
Yeah.
And like if they're stressed out because they're not comfortable in livestock scenarios, are you going to be feeding humans a bunch of stress hormone accidentally? I don't know. This
It explains so much.
It is something to consider, is all I'm saying.
Yeah. I think also that's a very good point about the animal husbandry aspect of it. Happy bees, now there's a whole thesis you can do about happy bees versus stressed, uncomfortable bees and foraging behaviors. And you can go
Happy bees, happy life.
Yeah.
There we go.
There you go.
Yeah. This is This Week in Science. Thank you so much for joining us for another episode. If you love what we do talking about science, please head over to twist.org and click on our Patreon link. You can choose to support us, as so many have done before, and your support really helps keep us doing what we're doing. This is This Week in Science. Hey, Justin, what you got?
Oh, my goodness. Have you guys ever heard of global warming?
What?
I think I've heard of that.
Maybe. a couple
Yeah.
times.
So it's this thing that we've
been banging the drum about. Yeah.
When we burn fossil fuels, it like coal, oil, and natural gas, it creates a heat-trapping blanket in our atmosphere, which raises global temperatures.
Yeah, it puts carbons in the atmosphere. So this is actually it's more of an article published in the Proceedings of the National Academy of Sciences based on a previous study that the folks who got together on this had been part of. It's an international team of researchers led by the University of Cambridge. They're asking for the Intergovernmental Panel on Climate Change to dedicate a future report to worst case scenarios. Apparently, the IPCC reports have been focusing increasingly on the least bad possible outcomes. Previous research that inspired this proposal showed that the majority of mentions by the IPCC in their texts talking about climate change and global warming are about the lower end of the climate change predictions. And anybody who's a long-time listener of this show knows that when these IPCC reports come out, every story after seems to say it's much worse than the predictions in there. And this might be part of why. They looked in this initial study at the ratio of studies looking at low, medium, and high end of century warming outcomes. And they found that they do not match at all the probability of those outcomes. As an example, dramatic worst case scenarios, temperatures of a rise 6°C or higher, has an actual probability of about 10% at this point. And yet it is far less than 1% of the mentions in the reports. The highest likelihood at the moment is that we will reach 3C. This is where we're tracking when we get to 700 parts per million carbon in the atmosphere. This is about 3% of the mentions. The attention overwhelmingly seems to go to the 1.5 to 2 degree Celsius temperature rise studies, which are centered around the goal setting that we have made, potentially leaving people, and by people, I don't know how much of the general public is getting this information sent out to them or hearing about it in the news, but this is the information that essentially is informing governments. 1.5 to 2 degree C studies are centered around the goal settings of Kyoto Protocol, potentially leaving people with the notion that the worst case scenarios of global warming are the ones that will occur if we hit all of the goals of the Kyoto Protocol, all the targets, which, guess what?
We're on target.
We're not. We ain't gonna do it.
We're going above and beyond.
So, Justin, I'm going to fight you now. So here's the deal. Crisis framing doesn't work. So even if it's realistic, if you talk about the worst case scenario, there is no motivation to fix things. This is proven social science. So I actually think this is really an interesting choice to potentially come up with a better outcome in the end. Because if you focus on the worst case scenario, you kind of guarantee it because people will not be motivated to do anything about it.
Okay, so first of all, I'm gonna push back. I'm gonna say, first of all, you said proven and social science. Which
yes. That's a thing. Don't tell me that's not a science, because it's a science.
I'm going to take an issue with that separate from this at some other point.
Wow. Okay.
At some other point, but
well, yeah, if you're talking some sort of game theory about when you're trying to convince people that a thing is a thing worth doing something about, what we're talking about here is an intergovernmental. The one report that everybody's pointing to as governments that they're basing decision making on for the future of the planet, and really thinking through what the climate change's dramatic problems could be, so that we can prepare for them. Whether we take it on and change it or don't, we're going to incur the actual causality of this happening over the next 100 years.
Right. So you're talking about it from an adaptation standpoint, which I understand what you're saying.
And
from a mitigation standpoint, that's what I'm talking about.
Well, even from a mitigation standpoint, then if the urgency isn't made as clear of what the consequences are, if you haven't attached the actual levels of risk and consequence, then how can you decide how much resource or how much effort and time to put into solving a problem? So on one hand, I kind of get the recycling doesn't do as much as you think it does, may prevent people from recycling. But when you're saying, maybe the house is only a little bit on fire, we shouldn't just run away and let it burn to the ground, you might need to rethink what you're
but you have to remember the politicians and committee members making these decisions are also people, and so they are governed by the same reasoning practices as people on the street. And so it's still an important thing to keep in mind that yes, talking about real life end game possibilities to adapt to a future is important, and I take your point there, but I also think it's important to remember that talking about worst case scenarios tends to move things in the wrong direction.
I want to just break this apart for a moment, which is the difference between the science that we're reporting and also the method of communication. And so what Justin is talking about is a scientific study that has determined some issues that need to be addressed seriously in the communication. But at the same time, Blair, you're talking about the strategy of communicating the risk to everyone, which is the importance of, understanding that there are solutions and that we can address all this, and there's still time to put our forces to change things. And so this is where the two things are kind of imbalanced, and where your disagreement is, where the crux of your disagreement really is stemming from. And I think that is really, it's hard in this kind of a podcast, right? Where we want to talk about science, right? We want to talk about the scientific studies. And so we're talking about a study that is bringing up a thing that is kind of a communication issue. And so then it's like, how should we report on it, right?
Mhm.
Should we be saying the basics and what the study's saying, or should we be just reporting the hard line of we can change things? I think these are very important questions as we move forward, because I think that's where this all comes from, where your conversation's coming from right now.
Maybe maybe I guess the thing is, I would have a hard time distinguishing the strategy of showing that we have time and there's things we can still do, and it's not going to be that bad if we do these things, and not focusing on the mean outcomes that are presented to us. I have a hard time distinguishing between that and the strategy of, let's not deal with global warming for the sake of our local industries, and give people the impression that there's plenty of time, that there's things that we can do.
There's not plenty of time. There are solutions, though. That's the thing. There's not plenty of time. There are solutions. That's
I think that's the difference, is that the best case scenario and the mean scenario are still bad. It's still not good.
So anyway, most of the coverage, most of the IPCC's reporting, let me reiterate this, over 50%, is about 1.5 to 2 degrees Celsius change, which we are already expected to go past, unless we have met all of the targets of Kyoto Protocol. So what my argument is that's underselling the severity of the problem.
Totally.
Which I feel like the intergovernmental panel is being pressured or pressuring themselves or
it's
selecting
politics. The whole IPCC is not there for science. It's there for politicians. The whole reason we have it is to make politicians happy. The whole reason we have it is to put together a nice story for politicians. That's it. And then the politicians take the nice story that the scientists put together. The scientists give them a scary story, and then it's made into a nice story for the politicians, and then politicians put it into an even nicer story for everybody else, for their constituents. Like, it's this trickle. It's awful.
So
like,
anyway,
what's really happening is not actually being represented by the IPCC.
Yeah, well, and
we
part
report
of the
on it,
problem
but
with
it's
that
not
is that there's
really
not enough scientists in politics, so it's getting lost in translation, and
but this is also anyway, what they're suggesting is an effort of really just focus. So some of the suggestions they came up with is focusing on 4 key strands of the studies and information that's out there: understanding extreme climate change dynamics and impacts in the long term, exploring climate-triggered pathways to mass morbidity and mortality, investigating social fragility, vulnerabilities, risk cascades, and risk responses, and synthesizing the research findings into integrated catastrophe assessments. They're essentially asking IPCC to face up to the bad to worst case scenarios. These include outcomes ranging from a loss of 10% of global population to an eventual human extinction. They want them to actually look at all the other things that are on the table that they have been avoiding talking about. The team behind the PNAS paper proposes a research agenda that includes these four horsemen of the climate endgame: famine, malnutrition, extreme weather, conflict, and vector-borne diseases. So it's a step beyond just talking about what the carbon level is, what a sea level rise is, or these sort of things that are somewhat, to a lot of people, maybe seem like abstract things to worry about. Famine, malnutrition, extreme weather, conflict, vector-borne diseases may be the thing that does get more attention.
I do think human health needs a better connector to climate change, because if you study the science, it makes perfect sense. But if you talk to a random person on the street, they have trouble connecting the dots of how climate change impacts human health. They just think about heat stroke pretty much. And that's it, right? And so I feel like that
I got heat stroke the other day.
You need help. You need help making that connection to the average person. I will, however, say calling it the Four Horsemen kind of feeds right back into that crisis talk I was talking about before that makes people want to not talk about it.
So can I ask though,
how do we do this? How do we go from the science to the messaging, and how do we get into a positive mindset of really, I mean, this study, I don't think is for, I mean, I'm just going to say it. I mean, podcast listeners, viewers right now, I'm sorry, this study is not for you. This study is for communicators, so that they can address communication better. That's what I think.
Well, this story is actually for the IPCC. It's an open letter asking them to make some changes in their focus.
But that's part of the problem too that I've seen over and over, is that a lot of times bits of the IPCC get released to the public in its entirety or in snippets, and it's just taken as it is, and that also is really tough for an average person to synthesize and not feel overwhelmed and just totally tune out.
The world's scary.
Yeah.
Oh my gosh.
Well,
the world is scary. It is scary. It is scary. The world's scary.
Sure.
It's scary, but dolphins are awesome. I'm going to talk about dolphins right now. I'm going to take us
totally awesome.
I'm going to take us from climate change to dolphins.
That's right. I asked for this. I asked for bring us back from the brink of the mass destruction, Kiki.
Somebody better have a happy story. Well, we all know that dolphins, like, they have their own language and they've got some really incredible behaviors and they do really cool things. Well, there's a new study that's out this week in Current Biology, in part from one of my previous research, my PI, Nicola Clayton from Cambridge University. She's working with researchers looking at common bottlenose dolphins to figure out whether or not these dolphins have episodic-like memory. And you go, Kiki, what's episodic-like memory? Well, episodic-like memory is when it's not just like remembering a thing. You're remembering all the stuff that goes around that thing. It's remembering what you did when you woke up in the morning, when you got that cup of coffee, how it smelled, who gave it to you, maybe not just where you put your keys, but why you put your keys there, what happened at that particular moment, what are all the contextual cues around that thing. Episodic memory is memory for episodes. And we know from research that humans have episodic memory. Now, in other animals, I've personally been involved in research with Nicola Clayton related to birds in the past, showing that scrub jays and some other birds have episodic-like memory, able to remember where they put food, what the food was, how long ago they put it there. They're able to remember these things. It's very important for survival, right? So, of course, dolphins, they're like people with fins who go, you know? Anyway, Anyway, so let's look at dolphins. And in this particular study, they looked at whether dolphins were able to encode spatial and social information, where a treat was given to them and who gave them that treat. So instead of just a where when, they're doing a where who kind of episode. And in this particular episode, the dolphins were able to very easily remember who gave them a particular treat at what particular time. And it's not surprising. I mean, honestly, thinking about dolphins and how smart they are, are we surprised?
No.
I'm not surprised.
I feel like most of I'm
not
the
surprised.
animals I took care of as a zookeeper could do this.
You think so, but nobody tests this stuff. And so this is kind of you to go, oh, well, duh. But then nobody's tested it before. And so it's this question of, do these animals have a similar ability to humans to be able to remember multi-contextual information? Social animals with a long life, you would think they have the ability to remember individuals and situations, right? It's going to benefit them socially. But we got to test it, right? So they did. And the dolphins were awesome. Dolphins win.
Test rhinos next.
let's test rhinos next.
This is off the beat. There was a story I didn't bring this week that was talking about the need to study shrunken heads in museums.
Yeah.
Like, apparently they've never been like genetically tested or CT scanned or anything. Like, how did you have these
shrunken heads
and never have studied them? Oh, we put them on museum because people come to see them. That's why. Okay, let's get some science on some of these things. But yeah, that's a great point. Like, that you may think that a thing has been studied, that nobody's taking the time to look at. Yeah.
Yep.
This is the one that was also a couple of weeks ago. I was talking about the ears, how they figured out warm-bloodedness because of correlation in the size of the ear canals, and they were able to go back through time and look at dinosaurs, all kinds of things that, based on the size of the ear canals, determine whether or not something was warm-blooded. Which they could have done that anytime. Still maybe questionable. Hadn't been done. And so if you want a job, if you want to find a career where it's like the open territory is still there to go out and explore and find new things, science has that opportunity. It's all over the place. All the science hasn't been done. All the things haven't been figured out. And if somebody gets to a point where they figured out that thing you're interested in, guess what? It will unlock a whole bunch of other things to go look at after.
Look at the
There's
things.
always gonna be more questions.
Look at the things.
Okay.
So my last story is that some researchers at Max Planck Institute of Molecular Cell Biology and Genetics in Dresden and the Max Planck Institute for Evolutionary Anthropology in Leipzig have discovered that neural stem cells, these are neurons, the cells from which neurons derive in the developing neocortex, they spend more time prepping their chromosomes for division in modern humans than they did in Neanderthals. How'd they figure this out? Well, they did a bunch of genetic sleuthing, and they determined that mice have the same genes as Neanderthals, and that humans are the ones who have these different weird genes.
Freak brains.
And so instead of comparing humans to Neanderthals, what they did is they compared humans to mice, really. And so in the comparison, what they determined is that because of the genes that are present, that are involved in preparing chromosomes, and when you're preparing the chromosomes, this is a possibility that you're dividing, you're translating things, you're moving things around. There's a possibility of errors. If you speed the process up, more errors can be made. If you slow it down, you can fix those errors. There's more possibility for fixing it all up. And so what they have determined is that because mice have the same genes as Neanderthals and humans have these weird mutations that slow things down comparatively, that what's really going on is that humans have more time for fixing errors. And so that's why our brains are better
than
Neanderthals. I mean,
Are you
mice.
sure?
I mean,
I was going a
Neanderthals.
completely
I mean-
different
Are you
direction.
Are you sure?
And I was thinking it meant that like we had to put more, eggs, in one basket as humans. Like we have to invest more in our babies. So now I was thinking about Neanderthals having litters.
I don't think Neanderthals had litters.
No, they definitely don't. But
Right, the
they
opposite.
might have had babies more often.
Less often.
No,
Right.
more
If
often
they had
than
if
humans.
they had babies more often, then that would provide time and offset the errors that were
It
being
would
made.
offset the errors because there'd be more opportunities for good babies.
No, they have less babies than current modern humans, and they develop faster.
They develop
They
faster.
grow up much
But
quicker.
they had less babies.
That's the thing.
They
They
had less
develop
babies.
faster.
And
Developing faster means more errors, and that's what
Yeah.
this
Yeah.
study's all about.
Yeah,
But why
yeah,
would they
yeah.
have less babies?
They had less babies because they were hunter-gatherers. I don't know why.
I know why. Why?
No,
Humans? Why are we
is that
weird?
is that a thing?
Yeah, so there's a lot of fertility issues that are linked to Neanderthal genes.
Oh,
Interesting.
And
interesting.
they lived in much smaller groups than the current modern humans. That's one of the theories of like that competition and the humans overtaking Neanderthals as a population. A lot of it might have just had to do with the fact that we have litters compared to them having a nice little nuclear
Right.
family and being like, that's it, I'm good.
I'm good. It's
Whereas we're just
fine.
like plopping them out all over the place, dozens and dozens of kids
Oh,
at a
boy.
time running around. Yeah. And they didn't
Dozens
have,
and dozens.
and they likely didn't have, as we were talking about before too, that the grandmother genes going on. So they also probably had less childcare
Mhm.
available, which is partly then again why those kids had to grow up quicker.
Interesting.
Growing
Okay.
up quicker with brains that weren't quite as good as ours.
Yeah.
We're gonna
And-
we're gonna stick to
but-
human,
but I do wanna-
humans are better. We're gonna stick
But
to
I
that.
do want to
Spell check.
I do want to tack one thing though, because there is a misnomer about hunter-gatherer cultures. This idea that they had to carry their children around with them, and therefore is like a reason they didn't have more kids. That apparently is not true. Most of your hunter-gatherers didn't actually it's not like they were nomads. Like, oh, what do we do today? Oh, let's keep walking in this direction. And they lived in seasonally, some years and years and years in certain locations, might have traveled seasonally a little bit, but it's not like they were just always wandering around. But anyway, I just wanted
I'm wandering around. I'm in
Yeah.
new places this week. Did we do it?
You are.
Did we come to the end of the show?
Yeah, that's the show.
The tight 90.
Tight 90. We got all our
Yeah.
stories in, everybody. Thank you so much, all of you, for joining us for this show tonight. We appreciate you being here. And I do want to give our absolute shout outs to Fada. Thank you so much for doing social media and the show notes that accompany our YouTube page. And thank you to Identity 4 for recording the show, and Gord and Aaron Lore and others for making sure that our chat rooms are happy, shiny places of hanging outness. And Rachel, thank you so much for your editing and other assistance. And I do want to thank our Patreon sponsors. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, Ralphie Figueroa, John Ratswamy, Carl Kornfeld, Carol Tazi, Woody MS, Chris Wozniak, Dave Bunn, Figured Chefstad, Hal Schneider, Jonathan Stiles, aka Don Stylo, John Lee, Ali Coffin, Gaurav Sharma, Reagan, Derek Schmidt, Don Mundis, Stephen Alberon, Derek Mashrek, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paula Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Base, Vote Beto for Texas, John McKee, Greg Riley, Mark Hesmerlo, Jane Tellier, Steve Leisman, aka Z, McKen Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Philip Shane, Kurt Larson, Kurt Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Nappy, O. Kevin Perrin, Chan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you so much for your support of TWIS. And if you want to help support TWIS, head over to twis.org and click on our Patreon link. On next week's show,
we will be back Wednesday, 8 p.m. Pacific Time, broadcasting live from our YouTube and Facebook channels, as well as from TWIS, TWIS.org/live.
Hey, do you want to listen to us as a podcast? Perhaps
Sure.
while you build something out of spider silk? I don't know. Just search for This Week in Science for podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes, links to stories, you can go to our website, www.twis.org, and you can click on the link, go read the actual study that was behind the story that you heard that you were interested in, and find out about the methods used in getting that information to you.
yeah.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into a pile of shrimp cement, and once it hardens, we'll never read it.
No, but as a time capsule, in the future, if Twitter's still around, you can hit us up there, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.